So here we have the problem, use CalcPlot 3D to develop the tangent plane and normal line to the following function. The function is z equals f of x comma y, which equals 4x divided by e to the x squared plus y squared at the point 0, 1. Step 1 is to consider the function z equals f of x comma y and a point on the domain x naught comma y naught, which gives a point on the surface x naught comma y naught comma z naught, where z naught equals f of x naught comma y naught. And for CalcPlot 3D, we need to graph the surface and the point. So first, we're going to need to find the point z naught. So let's put that in there. Okay, so z naught is going to be f of x naught comma y naught, which we know x naught is equal to 0 and y naught is equal to 1. So z of f of 0 comma 1, let's put the equation in here, is going to be equal to 4 times 0 divided by e times 1 squared, or 0 squared, plus 1 squared, which is equal to e times 1, e to the first power. So here we have 0 divided by e to the first power, which, as we know, 0 divided by anything is equal to 0. So our z naught, our point, is going to be x naught comma y naught comma z naught, which is equal to 0. Let's get rid of that naught. 0, comma 1, comma 0. Now let's go to CalcPlot 3D. So we don't need this equation. And let's add our graph, which is the function z equals f of x comma y. We can delete that other function. We have positive 4x divided by e to the x squared plus y squared. We don't need that plus 1. All right, so here's the graph of our function. Now let's add our point, which was, wrong thing, 0, 1, 0. And let's just double check that. Yep, 0, 1, 0. So the point is right here. It's a little bit difficult to see because it's right on an axis. Let's make that blue. Higher contrast. It's right there. Okay, so for step 2, we have fix the y variable to y equals y naught, and then consider the parametric curve r sub x of t. This means that we are going to parameterize x is equal to t and leave y as a constant. Our y constant is 1, as we know from above. So now we're going to write our new equation, which is vector r sub x of t, which is equal to, let's copy and paste our vector into there. We can replace y sub naught with 1, and f of t comma y naught is going to be our z-valued equation, or our equation from up above, with replacing y with 1. So here we're going to copy and paste that into this function. X remains the same. Actually, no, it doesn't. X is reparameterized as t. And then we have y is 1. 1 squared is still equal to 1. So we're going to have our new vector valued function is going to be t comma 1 comma 4t divided by e to the t squared plus 1 power. Now we are going to graph this space curve. All right, so let's go back to CalcPlot 3D, and we are going to graph this space curve. So we are going to add to our graph a space curve. So we know that y of t is a constant at 1, and then x of t is going to equal t, and z of t equals 4t divided by, in parentheses, e to the, open parentheses again, x squared plus 1. Close both parentheses. And then let's graph that. Oops, we have an x squared in here, which should be a t squared. And now we can see this space curve over with our point. And now we can play with the trace right here, so we can move this scroller and you can see that the vector is tracing out the curve that we just graphed. Let's click animate, and you can see that more slowly. Okay, so now for step 3, we are looking at r prime of x. So we're first going to take that's the same thing as our r of x function. We can copy and paste that, and then take the derivative of this. So let's do r prime of x of t. So the derivative of t is just going to equal 1. The derivative of a constant is equal to 0. And then we have to take the derivative of this section. This is going to require the quotient rule. So we are going to, let's do this in a separate spot. Let's copy and paste this over. Alright, so we have the derivative of the first, leave the second one alone, the second one being e to the t squared, t squared plus 1, that is in the exponent, plus 1, times, or minus, and then that's going to be, take the derivative of the second, leave the first one alone, so 4t times, that's going to be 2t e to the t squared plus 1, because e to the t squared plus 1 would equal u, and u prime is going to be 2t. And then we're going to divide that by e times 2 to the t squared. Okay, and then let's add that back in to replace what we currently have as our z value, or our function value. Alright, okay, so now we want to find that vector at r prime of t, and t being x naught. So I'm going to copy and paste this notation over. So this is going to equal, and then instead of t, we want x naught, and as we can see from above, x naught is equal to 0. So this is going to equal, we're still going to have 1, and 0 is the first two numbers, because those are both constants. Let's put that in there. And then we have, so 4e to the 0 squared is going to be the same thing as 4e to the first power. Minus 4 times, and that's times 0, so that whole term is going to become 0. So 4e to the first power divided by e to the first power squared, and then e to the first power is just equal to e, so that's going to be 4e divided by e squared, which is equivalent to 4 divided by e. So now you have 4 over e. And then we're going to want to graph on CalcPlot 3D, graph this vector and set the tail as our initial point over here. Okay, so let's go to CalcPlot 3D. Let's take out this trace. Let's add to graph a vector. So our vector was 1, 0, and 4 divided by e. Let's double check that. We have 1, 0, 4 over e. Yep, and then our initial point is 0, 1, 0. So 0, 1, 0. Now we can see that that has that same point right there on that graph. So just like how we found for step 2, we found r sub x, we are now, for step 4, going to find r sub y. So let's copy and paste this notation over here. We have r sub y of t. The x value becomes x naught. X naught is 0. So we have 0, comma t, as we are parameterizing y as t. And then f of x naught, comma t, so that's going to be f of 0, comma t. We can copy and paste our y, or our z function in there, parameterizing y as t. And into step 4, so here we have 4 times 0, which means that this whole term will always be 0 because regardless of what 0 is divided by, as long as it's not 0, it's going to equal 0. Alright, so that is going to be our vector. And it's now time to graph that. So we're going to go back over to CalcPlot 3D. You're going to add to graph a space curve. And we have x is equal to 0, y is equal to t, and z is equal to 0. And let's put that on the graph. So here we have it clearly going through the point. It's a little bit difficult to see. But yeah. There we have our space curve. And then if we explore the trace, we can go from here. You can see the vector right over here coming through and continuing on. So right about here, it's at our point. All right, so now on to step 5. Similarly, we are now finding the derivative vector at y. So we have r prime of y at y naught. So let's copy and paste the notation. We did the same thing for x. First, let's replace this with t, and then we can solve for t equals y naught. So the derivative of 1 is equal to 0, the derivative of 0 is equal to 0, and then we need to find f sub y of x naught comma y naught, or f of x naught comma t. So we are going to go up here and get our equation again, and copy and paste that into here. And now we need to take the derivative of this, but in this scenario, this is actually going to be 0, because 4 of x sub naught, as we found above, is 0. And this should actually be 1, not 0, because that is the derivative of 1, or the derivative of t. So if we have our prime y of t, where t is equal to y naught, and y naught is 1, that is still going to be the vector 0, 1, 0. So now let's graph that. So add to graph a vector, and we had that vector at 0, 1, 0. So let's add that to the graph. Oh, and with its initial point at 0, 1, 0. Let's change the color to green. You can't really see it right now because we have our other vector trace. If we take that trace off, you can see the red vector right there. So it almost doesn't look like this point was going through the different curves. So I turned one of them off and, okay, there we go. So before it kind of looked like a helix, and now you can clearly see that it resembles the graph. It goes over, it's definitely a trace of it. And then I'll remove the graph, and yeah, you can really clearly see this is with the two vectors going through that point, which is right there. We have the red vector, which is the one that we just solved for. It's with respect to y, and the black vector is with respect to x. Let's change that vector. Let's make it green, maybe a little bit darker. Okay, and then if we put the graph back up, we can see pretty clearly that it is a trace, and we can add in the other trace as well that goes straight through that y-axis. Alright, so now for step 6. Step 6 says, the two vectors are tangent to the surface and must, therefore, lie on the tangent plane. Crossing these two vectors will yield a normal vector which will help find the equation of the tangent plane. Note that switching the order of the cross product will also yield a normal vector, but going in the opposite direction. Find the cross product. So already written out, we have that r prime of x crossed with r prime of y. We have the notation in the matrix, and then we have the result. So that's going to be negative f of sub x, or the derivative with respect to x, at x naught comma y naught, and then negative the partial derivative with respect to y at x naught comma y naught, and then 1. So let's copy and paste this notation in, and then we already know these values, so we can go and substitute them in. So negative f sub x, or the partial derivative of f with respect to x at x naught comma y naught, we have over here, that's going to be our z value. If you recall that this was a function, and then at x naught comma y naught is going to be equivalent to 4 over e. So we have negative 4 over e, and then we have, with respect to y, and that is right here, we have 0. And that is going to be our normal vector, is negative 4 over e comma 0 comma 1. So let's graph that in CalcPlot 3D. Let's add another vector, and that was negative 4 over e comma 0 comma 1. And that's that black vector right there. And then we want to put our initial point at 0, 1, 0. And, okay, it's got updated. So now we have, with respect to y, with respect to x, and right here, which is a normal vector of that tangent plane. So now on to step 7. We are going to be using the point and the normal to find the equation of the plane. Now, as you can see, we already have all of this solved out. So when we solve for z, we can just plug in the values that we already have. So f of x naught comma y naught we found in one of the first steps, and we found that to be 0, 1, and 0. So f of x naught comma y naught is the z value of 0, 1, 0, which is equal to 0. So that's going to be 0 plus f sub x of x naught comma y naught, which we found earlier, and we found that to be 4 over e, and that was in step 3. So then we have 4 over e times x minus x naught, with x naught being 0. Next we have fy of x naught comma y naught, and fy we found to be 0. And then y minus y0, where y0 or y naught equals 1. But that's obviously not going to be important as we have a 0 multiplier. So simplifying, we get that this equals, so z equals 4 over e. Let's use proper notation for that. 4 over e times x. Because we are adding 0 and then adding 0 times y minus 1 is 0. Now we're going to graph this tangent plane. So we're going to go to CalcPlot 3D. We're going to add a function z equals f of x comma y. And we found that to be equal to 4 over e times x. So 4 over, let's put that in parentheses, 4 divided by e times x. Okay, and now we show up c, and we can see that that kind of slants right through if we remove our parameterized curves, we have just the graph and the normals, and you can see that this vector right here is tangent to the normal plane, and both of those vectors are on the normal, or are on the tangent plane. We can also take out our graph and add just the traces, and then you can see the trace and the slope, as well as the normal vectors. We can also take out the vectors, and then you can see the traces with the curve, and then the tangent. All right, and last but not least, we have step 8, which is you can find the normal by using the point and the normal vector, and then graph this normal line. So let's call this line, we can call it L of t, and that is going to be equal to the point, so that's going to be equal to x naught comma y naught comma z naught, so point, plus t times the normal vector. So we have the normal vector components is negative 4 over e comma 0 comma 1. So let's copy and paste this normal vector. Actually, we're going to want those angle brackets. So t times that plus a point. We know that that is 0 comma 1 comma, I believe 0. Yeah, let's check that. That's 0. So this is going to equal, we have negative 4 over e times t plus 0, comma 0t plus 0, and then we have 1 times t, also plus 0, or excuse me, this is going to be plus 1. So really we end up with negative 4e to the t, 1, and t. And now we're going to graph that normal line. So we can go over here, and we can add a space curve because we have the 3 parameterized components. And we have 1 was the y value. We had negative 4 over e times t for the x value, so negative 4 over e times t, and we have 1 and then t for z. So let's add that. We can see this curve. Let's deselect all of these other values to make the graph a little bit more clear. So we have, starting at this point and going out that way, we have our normal line. Now, we can see that being traced out by the vectors. And let's add our tangent plane so we can see that that is properly normal to the plane, and we can see that it's coming into the point right here. And that's it. And for the normal tangent vector, that is the negated version, which is why it might seem a little bit, it might go in the different direction than the plane that we used, than the normal vector that we used for the plane. All right, so that's it. Thank you.